Hello Year 12 Method students. In this video we're going to go through an example of how you can find the maximum and minimum values of a function, and particularly where we're taking into consideration restricted domains. We know that we can find maximum and minimum stationary points by identifying particular points where the gradient is 0, but it's important to understand that for certain functions, particularly with restricted domains, that a maximum turning point may not necessarily be the maximum value of a function, and a minimum turning point may not give you the minimum value of a function. And hopefully as we go through this example, you're going to kind of see what we're talking about there. So on this question, or in this question, we've got to find the absolute maximum and minimum values of a function f of x, which is equal to x cubed plus 6x squared, if the domain of f is either -7 to 1 or -5 to 3. Given it's a calculated question, and we're going to need to sketch the function anyway, or enter the function, let's put the function into our calculators and just see what it looks like. So we've got x cubed plus 6x squared. We're going to sketch that function. We can drag the equation onto our graph here, and we've got, well, a function where it looks like we can reasonably see the x-intercepts and a minimum turning point here close to the origin, or maybe at the origin. But we've got a fair bit of the graph going on, that we've got to look a fair way up the y-axis here. So rather than using zoom out, I'm going to use the window and just increase the maximum y value. At the moment, the highest y value on the graph is 4.6. I think it looked like we need to go much higher. So let's just go even to 100 and see how that looks. That might have been a touch too high, but I can sort of just tap and drag and get a reasonable view of the graph here. And so, well, even before we worry about these sort of domain restrictions, let's just have a look. We've got a maximum turning point that we can identify using analysis gsolve and then max. So we've got a maximum turning point at -4, +32, and we've also got a minimum turning point. So analysis gsolve min. Yeah, we thought it looked pretty close to the origin. It actually is at the origin 0, 0. But we've also got to factor in these domain restrictions. So if we look at part A, we're saying if the domain is -7 to 1, what's going to be the absolute maximum and absolute minimum values? So for example, if we investigate the point where x is 1, so if I use analysis and then gsolve, and what I'm going to do here is a y-calc. I want the calculator to tell me the y value when the x value is 1. You can see that that's going to be one of the endpoints of the graph. Okay, and we can find the endpoints that way, right? We can get the calculator to just highlight the point that is the endpoint, and we can do analysis gsolve y-calc again, and I can put in x equals -7. I've got a bad feeling this is going to go off the screen though. Yeah, it is. My y-axis doesn't go down quite far enough, but you can actually see that's telling me that the endpoint there would be -7, -49. But you can actually get your calculator to sketch the graph with the restricted domain, and that's pretty cool, and saves us having to, imagine cutting off parts of the graph. We can actually see the graph with parts cut off. If you go back up straight after the function you've input, if you use keyboard and then we're in Math 3 here, and use this little vertical line, which is a very helpful tool in lots of cases, we can actually input the domain. We can say we want -7 to be less than or equal to x, which in turn is less than or equal to 1. Right, so we're saying x needs to be at least -7, but no bigger than 1. And that's now the same function, but with a domain restriction. If I come back to my graph here, I can actually highlight and drag this function onto the graph. Oh, actually, I don't really like what it's done there. I'm going to go, let's see. Oh, I might just have to do a quick clear all, actually, because I didn't want the original function still to be there. So we drag this rule on with the restricted domain. Bear with me while I fix the window settings again. But you can see now that the graph has just been sketched with the domain restriction applied, right? And that lets us see a couple of things. It lets us see if we were looking for the minimum value of the function, it's going to occur at this endpoint. So even though we have a minimum turning point at the origin, the minimum function value is way over here on the extreme left-hand side. But when we're thinking about the maximum value, the highest y value, the highest function value, that is actually going to occur at this maximum turning point where x is -4. And so if we kind of were to sketch that out, and here's one I prepared earlier, it's written there, it's pretty easy to answer the question now from the graph, right? Because we've identified those key values. We can say the absolute minimum is -49 and the absolute maximum is 32. There's also, because there's a few ways to do this on the calculator, there's a nifty feature called Fmax and Fmin. So if you go analysis, gsolve, and Fmin, it'll actually highlight, as long as you've restricted the domain to what you need it to be, it'll highlight on the graph what the minimum function, or the minimum value of the function and where it occurs. So that's pretty handy. Likewise, we can do analysis, gsolve, Fmax, and it identifies the maximum value of the function. So for part B here, well, to answer part B, we just need to do the same thing as what we just did, but using the domain x is greater than -5, and I'm going to have to change that to a greater than. So x is greater than -5, but less than or equal to 3. So again, same function, just a different domain. And we're going to clear our graph just because we don't want to have two of the same function overlapping. And all right, I'm going to have to zoom up my y values a bit. Maybe not as high as I went before. Maybe 50 should do the job. Actually, I spoke too soon. I need to go even higher. Go. That looks like it's done it. You can see kind of it's just another section of the graph, but with these different domain restrictions. And we can identify all those key points, but now that we've seen that Fmax and Fmin, let's just go straight to using that. So analysis gsolve Fmin, 0, 0. So the minimum value of the function, and again, sorry, there's a quick sketch of the graph. Minimum value of the function occurs at the origin, where the function value is 0. Analysis gsolve and Fmax shows us that endpoint is actually where the maximum value of the function occurs. Even though we have a maximum turning point over here on the left-hand side, because of this new domain, the maximum value of the function occurs at the endpoint. And so our absolute min is 0, our absolute max is 275. Now, I'm going to show you one more thing that you can do on the calculator. You can use Fmin and Fmax without actually having to sketch the graph. So if we wanted to, we could go interactive calculation, interactive, I'm going to go and make a fool of myself. Interactive calculation. Oh, yes, I was right the first time. Interactive calculation, Fmin, Fmax. And if we want to find the minimum value of a function, we can go into this screen here and we're going to find Fmin. You type the expression in, which is just the right-hand side of your equation. So it was x cubed plus 6x squared that we'd been working with. The variable's x because that's the pronumeral we've typed in. Here, at the start and end, you just put in what your domain is. And so the default setting is a domain that's all real numbers. But say if we want to check our answer for part A, we could put the start value in as -7 and the end value in as 1. And it will spit out the minimum value of the function. Remember, this was the answer for part A, which was -49. And it also tells you the value of x, that the minimum value occurs. Okay, so even though it's often good to have the graph to look at, and I tend to prefer using Fmin and Fmax on the graph screen, it is worth seeing that maybe it's a little bit quicker if you just want to find the function value and you're not really interested in what the graph looks like. You can use interactive calculation Fmin, Fmax to identify those values. So if we, again, finally, just wanted to check the maximum value for part A to make sure 32 is correct, we could put the expression in again, x cubed plus 6x squared. Start value was -7, end value was 1. And we get, again, the maximum value of the function with that domain was 32, so that means we're right, and that occurs when x equals -4. So a few different ways to apply it. Good to know how to sketch your graphs and find your key points anyway, but a couple of handy tips there, I hope. One, with restricting the domain for graphs, but two, with also using that Fmin and Fmax function on your graph and in your main screen. As always, talk to your teachers if you need some help, but definitely practice your calculator use because it's going to come in very handy with all these applications of differentiation questions. Bye for now.